Trig substitution, integrals using trig substitution. I want to evaluate the antiderivative of dx divided by x squared root 9 minus x squared. Earlier, we looked at evaluating integrals using u substitution when I had a composite. Let's see if that method works here. What would I set u equal to? What's the inner function for my antiderivative? So if I try this, I minus x squared, then du would be negative 2x dx. But I have an x squared out in front, so that's not going to really work. We're talking about trig substitution, so we're going to try to draw a right triangle. The idea here is to try and draw a right triangle. Use some substitution with trig identities. Square root of 9 minus x squared, what I have here, as one of the side lengths in our right triangle. I'm going to draw a right triangle and use an acute angle theta to rewrite my antiderivative. I want to have the square root of 9 minus x squared be one of the three sides in my right triangle. If that's a side length in my right triangle, what would the other two have to be? What would the other two side lengths have to be? What would the hypotenuse be? Think about Pythagorean's theorem. If this is a 9, what does this have to be? What's Pythagorean's theorem? So what squared makes 9?
3.
What's the other side length have to be? X, good. Where'd you get the x from, Caitlin?
X squared.
What do you have to square to make x squared?
Definitely overthinking.
I gave you those two side lengths. I could express the third side length as root 9 minus x squared. Vice versa, if I give you root 9 minus x squared as one of the three side lengths in a right triangle, that means the other two would have to be 3 and x. I've got an acute angle theta. Let's write down what sine theta is equal to. It's not going to work in terms of x, so let's try and work it in terms of some angle theta referenced in this right triangle. SOHCAHTOA says sine theta should be equal to what ratio using our right triangle? Opposite over hypotenuse. What would that be? X over 3. Sine theta equals x over 3. That means that 3 sine theta equals x after I multiply each side by 3. Let's try cosine theta. What's cosine theta equal to in terms of SOHCAHTOA? Multiply each side by 3. Looks like 3 cosine theta equals root 9 minus x squared. In for root 9 minus x squared, I can substitute the trig expression 3 cosine theta. In for x squared, I can substitute quantities 3 sine theta squared. Root 9 minus x squared is 3 cosine theta. What am I missing? Dx. Well, if I know that x is equal to 3 sine theta, I can take the derivative of that, figure out what dx is equal to. What's the derivative of 3 sine theta? And for dx, I can replace 3 cosine theta d theta. So rather than terms of x, I draw a right triangle, label the side lengths correctly. I can substitute each of these different trig expressions in for the different parts of my antiderivative. That's what it makes sense. The idea here is to get one of the 3 sides to be whatever this radical is so far. Let's start simplifying this next. Here's how I can do to simplify my expression in terms of theta. What might cancel out or simplify? Cosine theta. See you later. If I square 3 sine theta, that's 9 and sine squared theta. So maybe I'll just factor out this extra 1/9 up front. Let's see, 1 over sine squared, what's that equal to? 1 over sine, the reciprocal of sine is which trig expression? Cosecant. Sine is 1 over cosecant, and 1 over sine is cosecant. So 1 over sine squared would be cosecant squared. So what I've got to evaluate is this antiderivative. 1/9 times the antiderivative of cosecant squared theta d theta. What is the antiderivative of cosecant squared? So negative 1/9 cotangent theta plus c. I wrote my integral in terms of theta using this triangle that allowed me to kind of work with, simplify some of these different trig values and trig expressions to be able to get to a way to evaluate my antiderivative. Antiderivative of cosecant squared is negative cotangent. So now I've got negative 1/9 cotangent theta plus c. Let's get this wrapped up though, because theta is not the original variable I was given my antiderivative in. I don't want my antiderivative in terms of theta, I want it in terms of x. Go back and use our right triangle to convert cotangent theta in terms of x. In terms of SOHCAHTOA, what's the ratio for cotangent? I know tangent's opposite over adjacent, so what would cotangent have to be? Yeah, adjacent over opposite. So from angle theta, it looks like the adjacent side length is root 9 minus x squared, and the opposite is x. Replace cotangent theta with what it's defined to be up from our right triangle up above. Now I have my final antiderivative. All this work with the right triangle, where I labeled one side as the radical 9 minus x squared, was to be able to use trig ratios to evaluate my antiderivative, just resubstitute my expression for x back in to find your final answer. Looks a little bit complicated, but after you do a couple of these, I don't think it's too terrible. Just gotta remember your SOHCAHTOA, I suppose. Let's try one more. do some rational exponents this time. All right, Justin, you guys see that okay? I know there's kind of a glare right there.
Yeah, all good.
Okay, yeah, we've got the antiderivative of dx over quantity x squared plus 1 to the 3 halves. Antiderivative of dx over x squared plus 1 to the 3 halves. This is a rational exponent. It's not really in radical form like it was over here. Of course, we can make it be in radical form. As a radical, what's the 3 halves exponent equivalent to? Is it the square root or the third root? Square root to what power, though? Third, okay. So let's rewrite this as the antiderivative of dx over quantity root x squared plus 1 cubed. Just like last time, we're going to reference Trig substitution to evaluate this antiderivative. I assigned root 9 minus x squared to a side length within my right triangle. Let's assign root x squared plus 1 to a side length in a right triangle. So that way I can write my antiderivative in terms of theta and use Trig substitution. Triangle here. Label angle theta. Let's get it started. Which of the 3 side lengths has to be root x squared plus 1? You think about it? All right, let's try. Jay says bottom. What will the other 2 side lengths be? What squared is 1 and what squared is x squared? Okay, so where's the x going to go? Where's the 1 going to go? Is x the hypotenuse or is x the other leg on the right? Say the hypotenuse. Okay, let's just try that. If that doesn't work out, then you can always retry. Let's see if this satisfies Pythagorean theorem. A squared plus b squared equals c squared. So root x squared plus 1 squared plus 1 squared equals x squared.
Austin Strong, please report to the secondary office.
When I square the radical, it cancels out to x squared plus 1. That look right? No. So I don't think I have my side lengths put together correctly. Where should I have put the root x squared plus 1? Hypotenuse. How do you know that, Hunter?
Because if you take x as one of the sides and one of the sides, square root of half.
Yeah. So a hypotenuse is the sum of the 2 legs squared in Pythagorean theorem. A leg would be the difference between the hypotenuse and the other leg squared. So let's see what we got here. I want to come up with a way to write what root x squared plus 1 is equal to in terms of a trig expression using that right triangle. I know sine theta is 1 over root x squared plus 1 because sine is opposite the hypotenuse. I don't want 1 over root x squared plus 1. I want the reciprocal of that. So what's the reciprocal of sine? Cosecant. Sine is opposite to hypotenuse, so its reciprocal cosecant would be hypotenuse to opposite. Hypotenuse is root x squared plus 1, opposite would be 1. So it looks like cosecant theta is equal to the square root of x squared plus 1. I now know what to substitute in for root x squared plus 1 for this part of my antiderivative. Let's come up with a way to get my dx figured out. Dx is the derivative of x, so I need an expression in terms of theta for what x is equal to. I know tangent of theta is 1 over x, but I don't want 1 over x. I want its reciprocal. I want x over 1. I'm not going to use tangent. I need to use the reciprocal of tangent. So that would be tangent theta. Tangent is opposite to adjacent, so cotangent would be adjacent to opposite. Of course, you don't pick those. You'll just have to do a little bit more work to get this to set up for you. Not the end of the world. Cotangent theta equals x over 1, or simply just x. If x equals cotangent theta, let's figure out what dx is equal to. What's the derivative of cotangent? Say again, Luke, say it. The derivative of cotangent? I think you're doing the antiderivative of something there. I look at my formula sheet here. The derivative of cotangent, I believe, is negative cosecant squared. Let me spot check that, though. Cotangent derivative, yeah, negative cosecant squared. Does that make sense now, Luke? Yeah, you were doing the antiderivative down below, if I look at that right. So negative cosecant squared theta d theta. So in for dx, I can replace with negative cosecant squared theta d theta. And in for root x squared plus 1 to the third, I'll have cosecant theta. Pause here. What's not making sense with how I've got these substitution steps put together?
It's not necessarily the substitution steps. Will you go over again how you figured out which side the Pythagorean theorem?
Absolutely, that's a good question. The Pythagorean theorem says what?
A squared plus b squared. C squared.
So let's solve for one of the legs. Let's solve for b. How do I get rid of a squared?
You move it to the other side.
Would I add or subtract from each side? I'm going to take the square root, right? So a leg is the difference between the hypotenuse and the other leg. When you see a difference here, it's got to be assigned to one of the two legs, otherwise it does not work out Pythagorean. Does that make sense?
Yeah.
Okay. Now, what happens if I have a plus in the middle? This one did. Wouldn't that have to be the hypotenuse now? Because to solve for c, you just take the square root of a squared plus b squared.
Okay.
Sum, it's got to be the hypotenuse.
Okay.
Difference, it's got to be one of the two legs. It doesn't matter which one you pick
Okay.
when it comes to one of the two legs. Does that make sense?
Yeah. Thank you.
Yeah. All right, let's simplify it. I've got negative cosecant squared over cosecant cubed. Anything to simplify there? Got cosecants on top and bottom. How many can I cancel out? 2 of them, right? 2 of the cosecants in the numerator cancel 2 of the 3 cosecants in the denominator. I've yet to take the antiderivative. I'm just trying to find the best form to be able to do so. That's why I put this in terms of theta using trig expressions, and then start simplifying from there. What's 1 over cosecant the same as? I suppose I can reduce that down. 1 over cosecant as a trig identity is equal to what? Cosecant and what are reciprocals? So 1 over cosecant theta should be the same as, ooh, close. 1 over cosecant is the same as, and I can take the antiderivative of sine theta pretty easily. What is the antiderivative of sine? I know the antiderivative of sine has to have cosine. The derivative of cosine would be negative sines. That looks fine. Looks like the sines work out the way they're supposed to. Are we done? What do I have left to do? Yeah. In terms of theta, my antiderivative of cosine theta plus c, but I don't want it to be in terms of theta. I want it to be in terms of x, because that would be the original variable for my antiderivative. So how can I get what cosine of theta is equal to in terms of x? I can use that right triangle again. For your SOHCAHTOA, cosine is what to what? Adjacent to hypotenuse? So adjacent would be x, hypotenuse is root x squared plus 1. Justin and Dustin, anything that I can answer for you